Hello viewers. In this video, I will give a quick overview of a simple microservice that uses PHP FPM, Nginx, Docker, and understand each part of the stack. At the end of this video, you will be able to understand how each of these components are configured, what those configurations mean, and how they interact with each other. Let's take a look at what happens when you make an HTTP request in the browser. The request is sent to a web server from your browser, such as Apache or Nginx, which then figures out how to forward the request to an application server, such as PHP FPM, and forwards the request data and headers using the application's expected protocol. The application server then processes the request and sends back the result to the Nginx web server, which then forwards the response back to the browser. Let's take a look at what PHP FPM is. It is an acronym for PHP Fast CGI Process Manager. It is the latest version of a process manager that allows execution of PHP scripts. It uses Common Gateway Interface Protocol, also known as CGI, which is an internet specification that enables web servers to execute an external program, typically to process user requests. It is optimized for web applications serving heavy traffic, featuring significant improvements over its predecessors such as Fast CGI or HHVM. This module comes bundled with the official PHP distribution since version 5.3.3. Moving on to the next part of our stack, Nginx. Nginx is a web server that can also be used as a reverse proxy, load balancer, etc. When used as a web server, it is used to serve dynamic HTTP content on the network using Fast CGI or other compatible protocols. It uses an asynchronous event-driven approach to handle requests, which helps in providing with more predictable performance under high loads. Nginx and PHP FPM combination is widely popular because it's a stable web server recognized for its impressive performance and low resource consumption. Let's look at some basic configuration for Nginx. The Nginx default configuration file is named nginx.conf, and it is usually found in /etc/nginx directory on a Linux-based machine. The way Nginx and its modules work is determined by the directives defined in the configuration file. Directives are divided into simple directives and block directives. A simple directive consists of a name and parameters separated by spaces and ends with a semicolon. A block directive has the same structure as a simple directive, but instead of a semicolon, it ends with a set of additional instructions surrounded by braces. If a block directive can have other directives inside the braces, it is called as a context. In this example, events, HTTP, server, and location are contexts. Directives placed inside the configuration file outside of any contexts are considered to be in the main context. In this example, the events and HTTP directives reside in the main context. The server directive resides in the HTTP context, and the location directive inside the server context. Before continuing on the remaining config in this example, let's take a look at our project files used for this video. This project was created using the Symfony framework. You will need to install Composer in order to be able to spin up a Symfony application. Once you spin it up, you should have a similar code structure as seen here, except for the Docker directory and the Docker compose file, which I have manually added. I will cover the part about Docker later in this video. As you can see here, we also have an index file within the public directory, which is the entry point for our application. Let's go back to the Nginx configuration. Generally, the configuration file may include several server blocks distinguished by the ports on which they listen to and by server names. We are defining the port 8120 on the Nginx server to listen for incoming requests. Once Nginx decides which server processes an incoming request, it tests the URI specified in the request's header against the parameters of a location directives defined inside the server block, and finds a matching pattern that can process the request. The try files command checks for the existence of files in the specified order and uses the first found file for request processing. The path to a file is constructed from the file parameter according to the root directive. In this example, Nginx will look for an index.php file under the app/public directory. The app directory is the directory where we will mount our project files to. How we do that will be explained later in the Docker section of this video. In our case, we use Nginx web server as a proxy server to forward the request to the PHP application server. The most basic Nginx configuration to work with the fastCGI server includes the fastCGI pass directive. This section will convert all the headers and data to be fastCGI compatible before forwarding the request for processing by the PHP FPM. The fastcgi.conf file contains all the basic configurations required for translating the HTTP headers into the fastCGI headers. In the remaining part of this video, we will look at what Docker is on a high level and how we can use it in our application to run a containerized simple microservice. Docker enables you to separate your applications from the infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same way you manage your applications. It lets you define all the infrastructure dependencies you need to run your application in a container. Containers are lightweight and contain everything needed to run the application, so you do not need to rely on what is currently installed on the host. You can easily share and port the containers between different machines, and you can rest assured that they will run in the same exact way. Let's look at the Docker architecture. Docker uses client-server architecture. When you download and install Docker Engine, you can run the client and daemon on the same system. Or they can be on a different system, and the client in this case can be a UI communicating with the daemon via an API. The Docker daemon listens for Docker API requests and manages Docker objects such as images, containers, networks, and volumes. Registry is where several images are stored. It can be public or private. Docker Hub is a public registry where anyone can publish their images to, so others can retrieve them and use it. Images are nothing but an artifact. Let's assume that our client is a command line interface. We can use the docker pull command to pull an already created image from the registry into the local machine, or we can use docker build command to build the image ourselves using the instructions we provide to Docker. Once we have an image built, we can use the docker run command to execute the application within the container. Let's see all this in practice. We will be creating an application that will need two services. One, the Nginx service, and another, the PHP FPM service. Now, in order to manage an application that has multiple services, each one running in their own containers, Docker provides a tool called Docker Compose to easily manage them. Docker Compose requires a YAML file which will define the various services and their configurations, such as the docker compose.yaml file that we can see over here. In this file, we define two services that we want to build and run, namely the PHP and Nginx. For the PHP service, we set the context to be the docker/PHP directory that will be used by Docker to build and run the PHP service. We also define that the Docker file is the file which will contain the instructions to build an image and run the container. In the volumes config, we instruct Docker to mount all the files from the current directory where the Docker Compose will be run from into the app directory inside the container. We have similar config for the Nginx service. The ports config instructs the Docker to map the physical port 8120 to the port 8120 inside the container. Now let's look at the PHP Docker file, which contains the instructions for the Docker to build an image. It says to use the PHP FPM as the base image defined in this line from the registry. And then we instruct the Docker to set the working directory to app directory for any subsequent Docker instructions. The expose command exposes port 9000 of the container to listen for incoming requests. And finally, we give the cmd instruction to start the PHP FPM service inside the container. The Nginx image instruction will look similar. We build an image based off of the image defined in this line from the registry. And then we copy the nginx.conf file from our repo into the containers/etc/nginx directory. And finally, we instruct Docker to start the Nginx service inside the container. Now let's use the Docker compose command to start up our application services. We will do this by using the docker compose up command and pass the -d flag to run the containers in the background. We can now verify that the containers are running by using the docker container ls command. Here we see that there are two services running, one for the Nginx and one for the PHP, as we have expected and have defined in our docker compose.yaml file. Now when we try to access an endpoint for our app, which I had already created before on the port 8120, we can see that it will return the response. Now, in order to stop our containers, we will use the docker compose down command. We will also pass the flag to remove any orphan containers. And now we can run the docker container ls command to verify that all the containers have stopped running. And with that, we have come to the end of this video. Thank you for watching and hope you found this useful. If you have any questions, comments, or feedback, feel free to drop in a comment.